Welcome to Narud Masters Academy, session number 4, module 10. Atoms and molecules. The topic name is atomic mass. In the previous session, we have discussed about the Dalton's atomic theory, which is proposed here, and then we'll discuss today the atomic mass. Here you can see the most remarkable concept that Dalton's atomic theory proposed that of atomic masses concept here. If you see the atomic masses concept, according to him, each element had a characteristic that is atomic mass. Since atoms are extremely light and small, scientists find it difficult to measure their individual masses. Okay. Hence, the mass of the atom is compared with the standard atomic mass of some other elements. So what happened here? So they made one standard for atomic mass of some elements, and with the help of those atomic masses of those elements, and they started finding the atomic masses of other elements. You can see here the best example. In 1961, it was universally accepted the mass of carbon is 12 atom would be used as a standard reference for measuring the atomic masses of other elements. So earlier, the scientists used hydrogen as a reference standard. So as we know, the hydrogen is the smallest one compared to all the elements, and its atomic mass also is very, very less. Since hydrogen has no neutrons, so if you see here atomic mass of a hydrogen, being the smallest atom is taken as a standard particles for comparing the mass of other atoms. Okay, hydrogen, helium, nitrogen, carbon, oxygen, sodium, chlorine, calcium, and if you see here nitrogen, one atom of nitrogen, its atomic number is 7, and its mass is 14. What is the atomic mass of nitrogen is? That is 14. So, and the atomic mass of hydrogen is 1 unified mass, 1 U. So, we have considered this hydrogen as standard unit. So, how many units of hydrogen is equal to 1 atom of nitrogen here? Very good. The 1 atom of nitrogen is also equal to the 14 atoms of or 14 units of hydrogen. So 14 atoms of hydrogen is equal to 1 atom of nitrogen. Is it right? So like that, we can find the any element mass with the help of this hydrogen mass. If you see, if you want to find for carbon, atomic number is 6, its mass is 12. So how many atoms of hydrogen is equal to 1 atom of carbon? 1 atom of carbon is equal to 12 atoms of, okay, 12 atoms of hydrogen. Is it clear? So in that way, earlier the scientist was used to find the masses of the other remaining elements. So therefore, the relative mass of nitrogen atom is 14. What is the relative mass of nitrogen atom? Is 14. What about carbon? Is 12. Oxygen, atomic number is 8. And here relative mass is 16 units of hydrogen. Is it clear? Now you can see here definition of atomic mass. The atomic mass of an element is defined as the average mass of all the isotopes of the elements as compared to 1/12 of the mass of one carbon atom. So as I told you just before, the carbon atomic number is 6, and universally accepted that the atomic mass of carbon is 12 atoms. So mass of carbon is 12 atoms. Then what is the mass of hydrogen? As we know that mass of hydrogen is 1. If you compare to carbon, what is the relative mass of hydrogen? 1/12 of carbon. 1/12 of carbon is equal to 1 atom of hydrogen. So how to remember? As we know that one atom of hydrogen is equal to 1 unit. Then one atom of carbon is equal to 12 units. Is it right? Then here if you want to find the atoms of hydrogen compared to this one, if how many units is equal to one atom of hydrogen, simply do the cross multiplication, then you will get very simple. So 1 by 12th of carbon is equal to hydrogen. If you want to find the relative mass of hydrogen with the help of carbon atom. So universally accepted that the atomic mass of carbon is 12 atoms. Is it clear? So very, very important point. You can see, imagine a carbon atom is like a watermelon. Okay. And then cut into 12 pieces here, which is cut into 12 equal pieces. Okay. So one piece represents 1 by 12 of carbon. Then what about 5 pieces? 5 pieces represent 5 by 12 of carbon. Then we know very well what is the atomic mass of hydrogen? 1. Then one piece is considered as a mass of hydrogen. So 1 by 12th of carbon. 1 by 12th of carbon is equal to hydrogen. Is it right? Now use these pieces to weight another atom as well. Now use these pieces to weight another atom. So you can see here, atomic mass of an element is a ratio and has no units and is expressed in AMU, atomic mass unit. So we'll represent in the form of AMU beside the number. It is unit. Actually, we'll consider no units, but atomic mass unit we call, or U is nothing but unified mass. Okay. So according to the latest IUPAC, okay, International Union Physics and Applied Chemistry, Pure Applied Chemistry, International Union Pure Applied Chemistry recommendations, the AMU has been replaced by U. So we know here International Unified Pure and Applied Chemistry. Okay, Pure and Applied Chemistry Organization recommendations is done here completely to replace this AMU by U, atomic mass unit. Okay, so instead of writing AMU, simply we can write it as U now, unified mass. Okay, so simply we can write what is the atomic mass of hydrogen means 1 U, carbon 12 U's. And then hydrogen 1, carbon 12, oxygen 16U. Okay, very, very easy to identify now. So look at here. What is the full form of IUPAC? International Unified Pure and Applied Chemistry. Remember the full form of IUPAC. It is very important for competitive spirit exams. Competitive exams, International Unified Pure and Applied Chemistry. Okay, International Unified Pure and Applied Chemistry is the full form of IUPAC. Now you can think here. How to weight helium atom then? What is the atomic number of helium? 2. Is it right? So look at here. 1 by 12 of carbon atom is 1 unit. Is it right? So the mass of one helium atom is 4 times of 1 by 12 of carbon atom. 4 times. So 1, 2, 3, 4. So simply add these all masses. 4 by 12, that is how much? 4 times of 1 by 12 of carbon atom. is nothing but 1 by 3. 4 ones are 4 3 times units compared to carbon atom. Okay. So atomic masses of few important elements you can note down here. For hydrogen, atomic mass is 1 unit. Carbon 12, nitrogen 14, oxygen 16, sodium 23, magnesium 24, and aluminium 27, phosphorus 31, sulfur 32, chlorine 35.5, and potassium 39, and then calcium 40. Very, very important. Sir, how to remember these all? No need to mug up. Let me tell you. Remember the element symbol and the name and the atomic number. You know, atomic number of hydrogen is 1. Mass is also 1. Okay. If you see atomic number of carbon is 6. Mass is 12. You know, atomic number of oxygen is 12. Oxygen is 8. Mass is 16. You know, atomic number of calcium is 20. Mass is 40. So, by observing this all, we can say that the atomic mass is almost atomic mass is almost double the atomic number. Atomic number. But for not for all elements, for few elements either less or more by 1 number. If you see sodium, atomic number is 11. Mass, it should be like around, as per our theory, as per our analysis, like what we can say, as per our guess, is exactly double the atomic number. It should be like 22, but here we are having 23. Oxygen atomic number is 8, mass is 16, nitrogen 7, 14, carbon 6, 12. Okay, magnesium 12, 40, 24, aluminium 13, 26, it should be like, but here 27 is there. Phosphorus and 16, 7, 31, sulfur and here 32, chlorine 17, it should be like 34, but here having 35.5. Potassium K 19, 39 is there. Actually, it should be like 38, and calcium 20, 40. So almost very easy to remember. Double the atomic number gives the mass of the element. Okay, very simple. Not exactly, almost. Okay, the chemical formula of compounds you can see here. Let's study how to write the molecular formula. You know, the following steps should be taken while writing the chemical formula of magnesium chloride. Magnesium chloride, magnesium is Mg and chlorine is Cl. How to write the chemical compound formula, molecular formula for magnesium chloride is very, very important. So based on this, we'll discuss very simple crisscross method. Write the symbol of each atom side by side. So write that one here first. Okay. Usually the cations first and anions next. Cation is nothing but positively charged, anion is nothing but negatively charged. Okay, magnesium is positively charged, chlorine is negatively charged. You can see plus and minus for these two. Now write the valencies of each atom above its symbol. So what is the valency of magnesium? 2. Okay, so you have to remember the valencies of each element. Chlorine 1. Okay, atomic number of chlorine is 17, its valence is 1. Magnesium atomic number is 12 and valence is 2. Now, crisscross method. Interchange the valency and write the number to the lower right of the constituents as their subscript. Mg, write this 1 here and 2 is here, Cl2. So it's a chemical formula of magnesium chloride is MgCl2. Whenever you will get this subscript to 1, no need to write that one. So simply write if any constituent receives the number 1, ignore it while writing the formula. Simply write MgCl2. What is the chemical formula of magnesium chloride? MgCl2. Okay. Then, now my question, write the chemical formula of sodium chloride then. First step, write the symbols of elements, sodium and chlorine. Okay. Atomic number of sodium is 11, its valency is 1. Chlorine valence is also 1. Write the valencies of each element at the top. Now, multiply this element with its valency. Okay. Multiply this one with its valency here and write its suffix of the subscript of this one and multiply this valency with this element. Then you will get Na1 Cl1. As we know that if any constituent receives the number 1, so ignore it and while writing the formula. So no need to write 1. So simply we can write it as NaCl. NaCl is the chemical formula of sodium chloride. Sodium chloride. Let me ask you one more formula. Write the chemical formula of water. As we know, water is H2O. How to write it? Write H, its valency is 1. Write O, its valency is 2. Okay. Now we know that it's we have to multiply with this one here and this one here. So 2 hydrogens and 1 oxygen. So we will not write this 1 while writing the chemical formula. So chemical formula of water is H2O. Okay. So in this way we can identify, let me give few more examples so that you will get clear idea about how to write the chemical formula of molecules. If a constituent has more than one atom, enclose it in brackets. Okay. Formula of calcium oxide. First write the symbols of each element, calcium and oxygen, and then their valencies. Here calcium valency is 2, oxygen valency is also 2. So as we know that here we have to write like Ca2 and O2, is it right? Whenever the valencies are same, no need to multiply that number here. Here the valencies of the two elements are the same, is it right? So basically we'll get here Ca2O2, but we simplify the formula as CaO. Okay, we are having Ca2 by multiplying this and O2. Whenever we are having these two, simply we can remove this as a one quantity here. Instead of writing 2 units, CaO is as 1 unit. If you want, you can multiply here 2 times of CaO. Okay, so this is the simple way to write the chemical formula of any molecules. Or chemical formula of one more. Let me give calcium chloride, calcium hydroxide now. Write the symbols of formulas, calcium and hydroxide, OH. So valencies is very, very important. Calcium valency is 2 and OH valency is 1. Do multiplication here. And then calcium, its subscript is 1 and OH subscript is 2. Here if you observe, 2 elements together are there. So overall the valency of this element is OH is 1. So we have to keep the bracket and then we have to multiply with 2. So its formula is Ca 1 time and OH 2 times. So 1 no need to write here. CaOH taken twice. Note that the formula of calcium hydroxide is CaOH taken twice and not CaOH2. Don't write that like it as CaOH2. This is wrong. You have to keep the bracket whenever 2 elements together are there. We use brackets when we have 2 or more of the same ions in the formula. Then tell me what is the chemical formula of magnesium oxide or magnesium hydroxide? Magnesium hydroxide, OH. Valency of magnesium is 2, valency of OH is 1. So simply multiply. Then Mg is 1, OH is 2. So no need to write this one. Then the formula is MgOH taken twice. Is it clear? Very, very important. Here, the bracket around OH with a subscript 2 indicates that there are two hydroxyl OH groups joined to one calcium atom. In other words, there are two atoms each of oxygen and hydrogen in calcium hydroxide. Okay. Now, if you see here, molecular masses and numericals. We'll complete with this topic for today's session and then continue in the next session. Molecular mass. The molecular mass of a substance is the sum of the atomic masses of all the atoms. For example, if I'll ask you to find the atomic mass or molecular mass of carbon, you know atomic number of carbon is 6, its mass is 12. Is it right? What is the mass of carbon? 12 units. Now, if I'll ask you to find what is the mass of oxygen, then you know very well oxygen atomic number is 8 and mass is 16 units. Then the question is, find the atomic mass or molecular mass of carbon dioxide. Carbon dioxide. CO2 is the carbon dioxide. Find the atomic mass or molecular mass of carbon dioxide. As per the statement here, the molecular mass of this substance is the sum of the atomic masses of all the atoms in a molecule of the substance. Here it is a molecule CO2. If you consider, for example, molecular mass of CO2 is mass of C plus 2 times. Why? Because here 2 is there. 2 times of mass of oxygen. Is it clear? Now you know what is the mass of carbon? 12 plus 2 times of what is the mass of oxygen? 16. That equal to 12 plus 32, 44 units. 44 U. Okay. So what is the molecular mass of CO2? 44 units. Is it clear? Let me explain one concept. Calculate the molecular mass of HNO3, nitric acid. Okay. So to find its mass, first split the terms or split the elements. How many hydrogens are there? 1 into atomic mass of hydrogen plus how many nitrogens? 1. 1 into atomic mass of nitrogen plus how many oxygens are there? 3. So 3 into atomic mass of oxygen. Right. What is the atomic mass of hydrogen? 1 plus nitrogen is 14. 1 into 14 plus 3 into atomic mass of oxygen is 16. So 1 plus 14 plus 30 plus 18, 48. 58 plus 1, 59 plus 4, 63 units. What is the molecular mass of HNO3? 63 units. Is it clear? Here you can see the steps. 1 into atomic mass of hydrogen. This hydrogen, only one element is there. Plus 1 into atomic mass of nitrogen. This is the nitrogen. Here you can see only one nitrogen atom is there. Plus 3 into atomic mass of oxygen, this element. Okay. Write the atomic masses 1 into 1 plus 1 into 14 plus 3 into 16, that equal to 63 units. So what is the atomic molecular mass of HNO3? 63 units. Okay. Now my question, can you find molecular mass of HCl? Very easy. hydrogen, 1 into hydrogen, atomic mass of hydrogen plus chlorine. Only one chlorine is there, 1 into atomic mass of chlorine. That equal to 1 into 1 plus 1 into 35.5. That equal to 36.5 total. 1 plus 35.5. So total is 36.5 units. Is it clear? Molecular mass is equal to sum of the atomic masses, as we know. H2O. Very easy to find now. How many hydrogens? 2. 2 into atomic mass of hydrogen plus how many oxygens are there? 1. 1 into atomic mass of oxygen. So you know very well 2 into atomic mass of hydrogen is 1 plus 1 into atomic mass of oxygen is 16. That equal to 2 plus 16, that equal to 18 units. Is it clear? Very easy. So number of hydrogen atoms into number of atomic mass of hydrogen, number of hydrogen oxygen atom into atomic masses of oxygen. Simply write here. Number of hydrogen atoms are 2 here. Atomic mass of hydrogen is 1. Number of oxygen atom are 1 and atomic mass of oxygen is 16. Okay. Then 2 plus 16 is equal to 18 units. Is it clear? Now find atomic mass of hydrogen and atomic mass of sulfur. What is this? Calculate the atomic mass of sulfuric acid, H2SO4. Do it fast. Take 1 minute time and then complete it. H2SO4, 2 times of hydrogen atom or atomic mass of hydrogen plus S, 1 into S plus 4 into oxygen. Okay, 2 into hydrogen atomic mass is 1 plus 1 into sulfur atomic mass is 32 plus 4 into atomic mass of oxygen is 16. So 2 plus 32 plus 4 into 16 is 40 plus 24, 64. That equal to 98 units. Very easy answer, which is already given here. Is it right? So let me stop the session for today here. Then we'll continue in the next session with mole concept theory. Okay, we'll continue in the next session with this mole concept theory. Thank you.